What if I told you that humanity is working together in a collaboration to engineer the most perfect superbug? A superbug that could withstand all of our medical advances and jeopardize our public health. Now, before I explain, let me give you a scenario. Imagine an individual who gets infected with pneumonia. Now, he gets sick, he gets a high fever, starts coughing violently, so they decide to go to the hospital for treatment. The doctors at the hospital diagnose the patient with bacteria-caused pneumonia and prescribe a series of antibiotics. But to their surprise, none of the antibiotics is working. So as a last hope to save the patient's life, they prescribe a last resort antibiotic, an antibiotic that's only ever prescribed if everything else failed, called tigecycline. Now, whether tigecycline works or not will mean life and death for the said individual. So it becomes a question or problem of how are these microorganisms developing this resistance to these antibiotics. Every single time throughout history we develop or discover a new antibiotic, within a decade's time you see resistance to it. So it becomes utmost important to preserve the antibiotics we currently have in order to protect their effectiveness. What I'm interested in is not just the clinical aspect, but the environmental aspect as well. For example, when we take antibiotics, it goes out to our gut and it kills our microbiota, except for the resistant bacteria. Then when we go to the bathroom, we flush it through our system, including the residual amount of antibiotics, and it goes into our water. Now, the water needs to be cleaned, so it goes to a water treatment facility, such as a wastewater treatment plant. Now, the wastewater treatment plant uses bacteria to clean the water, but now we introduce antibiotic-resistant bacteria into the population. As seen in the top image of my slide, you can see that bacteria are capable of taking genes from surrounding dead cells, incorporating them into themselves, and furthermore, they're capable of passing these genes to surrounding members, therefore proliferating that resistance throughout the entire population. So what I've done so far is I've taken samples from Toronto's wastewater treatment plants, and I found numerous amount of bacteria showing high levels of resistance to tigecycline. As you can see by the bottom image of my slide, is that as we increase the concentration of this tigecycline, the resistant bacterial store grows, indicated by the streaks of lines on the bottom of the petri dish. Whereas in comparison to the sensitive culture, we see no growth at all. So what I'm really interested in is how are these microorganisms developing such high resistance to this antibiotic tigecycline? And can we prevent the rise of superbugs? Thank you very much for listening.